In any closed system, energy is conserved. This means that the total amount of energy in the system remains constant. However, in some collisions, energy is not conserved. This is because the energy can be converted into other forms, such as heat or sound. When two objects collide, the change in their mechanical energy is determined by the elasticity of the collision. If the collision is perfectly elastic, then the change in mechanical energy is zero. If the collision is perfectly inelastic, then the objects will stick together and the change in their mechanical energy will be equal to the work done by the forces during the collision. In between these two extremes, the change in mechanical energy will be somewhere in between. The more elastic the collision, the closer it will be to zero, while the more inelastic the collision, the closer it will be to the work done by the forces. To calculate the change in mechanical energy, we need to know the elasticity of the collision and the work done by the forces. The elasticity is simply the ratio of the change in kinetic energy to the change in potential energy. If the elasticity is equal to 1, then the collision is perfectly elastic. If the elasticity is less than 1, then the collision is inelastic. The work done by the forces is equal to the change in kinetic energy plus the change in potential energy. If the forces are conservative, then the work done is equal to the change in mechanical energy. For an inelastic collision, the work done by the forces will be greater than the change in mechanical energy. So, to calculate the change in mechanical energy, we need to know the elasticity of the collision and the work done by the forces. We can then use these values to determine the change in mechanical energy. If you have any questions, comments, or suggestions, please drop them in the comment box below. For more about this topic, and access to this virtual simulation, I have left an access link in the description box. If you enjoyed the content of this video, kindly subscribe to my channel. Also share and like. Enjoy the rest of the simulation.